Hi, in this session we will discuss about introduction of algorithm and its analysis. This module contains the introduction to the algorithm and performance is measured by using the asymptotic notations, and also it will identify the differences between best case, average case, and worst case behavior of algorithm. Here we will see the definition for the algorithm. Algorithm is having set of statements. That statement should be finite. Finite in the sense countable number of lines. So the algorithm should have finite set of statements. That statements guarantees to provide an optimal solution to the given problem statement in finite interval of time. So the algorithm is having set of statements that should provide best solution for the given problem statement within given interval of time. Which are the algorithms said to be best algorithms? The algorithms are consuming less time, and also the algorithm is consuming less memory space to store the data. If the algorithm is satisfying this both conditions, then that algorithm is called best algorithms. For example, for given problem statement, or for adding two numbers, so for adding two numbers we will have two variables. In these variables we will assign some values. So, one algorithm may have 10 lines of code, and another algorithm may have 15 lines of code, and third algorithm may have 7 lines of code. So here we assume three algorithms have been written for adding the two numbers using the 10 lines and 15 lines and 7 lines. So here each statement may have some operations. So here the whichever algorithm is taking less time for execution, and also which is consuming less memory space to store the values in the memory, so that algorithm, among this three algorithm, whichever algorithm is consuming less memory and less time, that algorithm will be called good algorithm among these three. So whenever the software engineer designing the algorithm, he should consider the computational resources of for checking the time complexity of algorithm. Here, how to measure the algorithm's efficiency? Here, the amount of resources consumed in solving a problem depends upon the input size n. The algorithm's performance depends on time and memory space, and also when the new algorithm is developing by the software engineer, he should consider the six factors. First factor is hardware of the system. So this hardware should support to our newly designing algorithm, and also operating system, that is also to be considered. Like if we are designing the new algorithm, that should support by the given operating system, and compiler, size of the input, nature of the input, and algorithm. So these all six resources are to be considered when designing the algorithms and also measuring the performance of the algorithm. So here, which one to be improved? The hardware is fixed, so we cannot we cannot change the hardware every time when you are measuring the performance of algorithm. And operating system also fixed. Compiler is the software which is also fixed when measuring the performance of any algorithm. Then size of the input, the size of the input may vary from 1 to n number of inputs. And nature of input in the sense that input may be numerical data or text, categorical data, or video or image. So different nature of the data. And algorithms, number of lines in the algorithm. So which one can be modified when measuring the performance of algorithm? So the algorithm, number of lines in the algorithm can be improved when we are measuring the algorithm's efficiency. So here, to measure the algorithm's performance, we are having one of the approach, order of growth of given functions. So which is the function? Here, the each and every algorithm will be considered as a function depends upon the input size. So that function, how it is growing when the input of given algorithm is varying. The order of growth provides the behavior of a algorithm, how it is behaving, how many steps it is having, how many operations which is having. So that is the behavior of a algorithm. The order of growth gives a simple characterization of algorithms efficiency. Algorithms efficiency in the sense time complexity and space complexity, which is allowing the software engineers to compare the relative performance of alternative algorithms. As I told you in the beginning, the addition of two numbers may have different three number of algorithms. First algorithms may have 10 number of lines, second algorithm may have 15 number of lines, third algorithm may have 7 number of lines. Here each algorithm will have its own execution time. Then we can compare its execution time. For example, first algorithm may take 2 seconds, second algorithm may take 4 seconds, third algorithm may have 1.5 seconds. So here we can compare which algorithm's execution time is less. The order of growth means when you are increasing the input size, the time of execution also will increase. So that is measured by or defined by using the order of growth of function. When we are increasing the input size, which is really impacting the algorithm's performance. For example, here the running time of the algorithm is depending on the size of the input and nature of the input. So when you are increasing the size of input from 1 to n, automatically the execution time of the algorithm is increasing. Here the running time is measured in terms of number of steps in the algorithm and the primitive operations in every statements. So number of statements in the algorithm and also primitive operations in the each and every statement. So what are the primitive operations? Expression evaluation. What is the expression here? Expression means any statement which is having a additional arithmetic operation, relational operation, logical operation, like that. So this is called uh, expression. So evaluating this expression. So this evaluation is this evaluation will take some units of time for execution and assigning a value to the variable. So here we are assigning the value to the variable c and indexing into an array. If we are using the array variable, then we will give the index. So for each index it will consume 1 unit of time. Then method calling. So suppose if we are using the method, then we will call the method sum of n numbers. So this is the method calling. So this statement will consume 1 unit of time. Then return statement. So these are all some example for the primitive operations. So running time is depends upon the number of steps and primitive operations available in the algorithm. Nowadays, we are having the 64-bit operating system and 64-bit hardware architecture. So the performance of algorithm is not entirely depending on hardware and operating system. It is mainly depending on the number of lines and primitive operations in the algorithm. What is the asymptotic complexity? The asymptotic complexity is used to measure the behavior of algorithms execution time. Measure the behavior of algorithms execution time, which is measuring the algorithm's performance by changing the input size. By changing the input size from 1 to infinity. When you are feeding single input to the algorithm, what is the execution time? And when you are increasing the input size into infinity gradually, then you will get different execution time. So based upon that, we can measure the algorithm's performance. Mostly the performance of algorithm will be denoted by using the big O notation. For example, for linear search algorithm, the order of n is the time complexity. For binary search, order of log n is the order of log n is the time complexity. So here big O is the notation which is used to denote the time complexity. For example, how we are measuring the algorithm's performance is given here. The input is array of n numbers. N is the number of integers. Then output is sum of all numbers using array. So here the method is defined in Java. Public is the keyword. Then integer is returning data type. Sum is the method name, which is taking two arguments. One is the array a, second one is the n number of integers. Here s is the initializing the value for sum of n numbers, s equal to 0. Then for loop, which is initialization I equal to 0. Then which is moving step by step until n minus 1. Then so n number of integers will be considered in this sum of n numbers. Then here which is having the arithmetic operation and assigning that value into variable s. Finally, which is returning the s value. Here, how should we analyze this algorithm's performance? You look at here, this method starts the execution. Here the integers s equal to 0 is the first statement which will be executed only once in this inside the block. And inside the for loop, this I equal to 0 is the second primitive operation which is executing only once. Then third primitive operation, comparison of I value and n value, right? So which will execute n number of times, so n times, right? Then I plus plus is the fourth primitive operation which is also running n times. Then assignment operation, then next primitive operation which is also running n times. Then addition operation which is the sixth primitive operation which is execute for n times. Then indexing, array indexing is the seventh primitive operation which is also executed for n times. Then finally, after getting the result in the value the variable s, which is returning the value s, so which will execute only one times. Here when you are looking counting this, we are getting different number of ones. You look at that, here one is available one time, this is one time, then here s is executing for one time. So totally three statements are executed only once. But here n is n number of times these primitive operations are executing for n times, so 5 n's are there. So here we can computing the time complexity as order of 5 times of n plus 3 single time execution statements. So this is the time complexity for this algorithm which is given here. So the order of growth is 5n plus 3. The time complexity is 5n plus 3. Here when we are increasing the n value, our f of n is 5n plus 3, 5n plus 3. When you are increasing the n value, when you are increasing the n value, you will get different number of execution steps. Your if when your n value is 10, then you will get 5 into 10 plus 3, 53 steps. So when you are increasing the 100, you will get the 503. When the 1000, 5003. If it is the 10 lakhs, you will get the 10 lakhs, 50 lakhs 3. So when you are increasing the input from 1 to 10 lakhs, 1 to 10 lakhs, then you are checking, the execution time of algorithm, performance of algorithm. So here you look at that the number of steps is growing linear proportion to the input size n, input size n. That is the observation you should get from this content. Right now, in this 5n plus 3, which term is dominating? Either this 3 or 5 or n, which is dominating in this function 5n plus 3. You look at here, when n is getting large, when n is 1, when n is 1, this two terms 5 and 3 getting very much importance. For example, if n is 1, then f of 1 is 5 of 1 plus 3, so totally 6 steps, sorry 8 steps, 8 steps. But when you are increasing the n into large 1000, right, you will get 5003 steps. Here when you are comparing the 5000, 3 is very insignificant, very low number. So the 3 is becoming insignificant value for large n value. So you can drop that value. And also 5 is inaccurate in the sense, for different operations it will change, it will change. For example, um, if you are having any one another statement, other statement, then for example you see here you are returning the value yes, returning the value yes. Okay, and here we are initializing the value s equal to 0. For example, if you are using one more statement, integer name, sorry, uh, character name, character name, this is also will execute one time, will execute one time. So now the single time execution statements are increasing, so 4 will come, 4 will come, right? And also here we are having the 5 ends, 5 ends. Suppose if you have print, here again we are having assigning the value for the name B. So here which also will execute n times. So the we will have 6n, 6n. So the 5 is the coefficient value is also varying, depends upon the operations, depends upon the operations. So this is also not having any importance. So what to do? The lower order terms can be dropped from the function, and also the coefficient can be dropped from the function, order of growth function. So now that when you are dropping order of 5 n plus 3, when you are dropping 3 and 5, you will get the time complexity is order of n. So when you are increasing the large value, right, your time complexity of the given code is order of n. Mostly algorithm is depending on the input size n, that is the thing. So which is said to be, it is growing asymptotically using the value of n. Now we are having so many asymptotic notations to measure the performance of algorithm. So here we are having the asymptotic notations. Notations is the symbols, symbols which are like a languages, which is are like a languages used to analyze an algorithm's running time, algorithms running time by identifying the algorithm's behavior. So asymptotic notations are the symbols which is assuming as a languages which are used for the software developers to measure the performance of algorithm by identifying the behavior of algorithm. Here the running time is increasing by increasing the size of input, and also the algorithms performance is analyzed by defining the mathematical bound or framing its runtime performance. The asymptotic notations are 5 types. One is big O notation, which is representing the upper bound, and also small o notation, big omega notation, small omega notation, which both are representing the lower bound, and theta notation, which is representing the tighter bound of function, which will be explained in next section. Thank you.